Lesson 119, number 18. We're supposed to find the region of interest, and then we're supposed to plot points that are within the region of interest. So this thing's a cubic. We're supposed to also use our knowledge of the basic shape. First, let's do the region of interest. So you look at the coefficients of all the terms, and you find the biggest one with the highest absolute value. So it doesn't matter if you use this 2 or this one. The absolute value of 2 is 2. You add 1 to it, and that's 3. So then I sketch a graph just with only 3 points going up, 3 down, 3 right, 3 left. Because this is this circle with a radius of 3, where all my turning points are going to happen, and all my intercepts. So then we plug some points in. I just start with 0. I usually draw a t-table, and then I put 0 like halfway down the table, because sometimes, like, I'm not going to bother plugging the 3 in, because when I plugged in 2, I got a big number that I didn't feel like graphing. So, and I'm not going to, the -3, that's too big of a number. I don't want to graph anything outside there. So start with the 0, see what you get, then maybe try the 1. Once you get too big, you don't want to go that way anymore, and then I start going up here. -1, I got 0. -2, I got 0. I was pretty interested about that. -3, it got kind of high. I didn't want to plot that one. And so that's pretty fast. I don't have to plot that many points. If it wouldn't have said use region of interest, I probably would have just found the zeros using synthetic division, but it told us to do it this way, so we're going to do it this way. So plot the 1, 2, 3, 4 points. So I just had these 4 points, and then I have to use my knowledge of what shape. The lead coefficient is a 3, which means it's a cubic, which means it's going to have a shape kind of like that. Okay, when the lead coefficient has an exponent of 1, it's just a line. If a lead coefficient has an exponent of 2, it's going to be some kind of parabola where both ends point up. The lead coefficient is 3, and there's no minus sign in front of it. Sorry, I said the lead coefficient. The degree. All these things I'm talking about, the degree. The exponent. If the exponent is 3, I have a cubic. If the exponent is 4, I have a quartic. If the exponent is 5, I have a quintic. Notice that, and if the exponent is 6, I don't know what that's called, but it's a 6. Has a lot of turns in it, right? And it's even, so both arrows point in the same direction. Odds, they have the arrow on the right points up and the arrow on the left points down. The turning points are going to be 1 less than whatever the degree is. So anyway, I know that it's going to be shaped like this. Well, if I've got these dots like this, and I know I can look right here and I go, oh, 212, that's way up there. So it's going to have to come down. Oh, did I not even graph it yet? It's going to have to come down. Oh, oops. Sorry, that was the wrong graph. That was when I plotted some points wrong. It's going to come down, and it's going to come up. Now, we don't know how high it is going. We're just sketching it using the region of interest. And so that's it.